Okay, so what I have here is I have how many graphs do I have here? I have 12 graphs in front of us. So our first challenge is to figure out, all right, which one of these graphs are polynomial in nature and which ones are not. And then we'll do some more things with that. But let's just go ahead and talk about, right, what we need to be a polynomial is we need to be smooth and continuous, right? And so this is basically smooth and continuous. We know it to be a line. This one's smooth and continuous. It's a line. So we clearly know that this is a polynomial and this is a polynomial. And here we have a nice smooth and continuous arc. And it looks like a parabola actually, right? So that's a polynomial. Again, here we have a nice smooth curve. So this is a polynomial, right? Here we have a nice smooth curve. So that's a polynomial. Also notice that the end behavior is unbounded, right? So it's going to positive infinity and negative infinity. Positive infinity and negative. Here we're going to positive infinity in both directions. Negative infinity to positive infinity. Negative infinity in both directions. Smooth and continuous and unbounded behavior. So this is a polynomial. Smooth and continuous unbounded behavior, right? So polynomial. And then we run into this guy, all right? So far everything's been nice and polynomial-like, and then we hit this crazy graph right here. So on this graph, the good news is that it's nice and smooth and it's continuous, right? So no hard cusp, no corners. I can trace it without ever lifting my pencil. But what's wrong here is the end behavior is wrong. What it should be doing is going to either positive infinity or negative infinity, but it looks like this guy's hugging the x-axis. So for that reason, this one is not a polynomial because the end behavior doesn't do what a polynomial does. In the next graph, we're smooth and continuous, and we're unbounded, right? We're going to positive infinity in both directions. So this is definitely a polynomial. Here, the end behavior is good, right? We're unbounded, but as I trace the graph, it's continuous, but what I have are some unsmooth transitions. We have some corners there. So we're looking at what are called cusp. So this is not a polynomial. It almost is one, right? Because it does all the other stuff. It's smooth, it's continuous and unbounded, but it definitely not smooth. For the next one, again, we have a nice smooth and continuous curve, but the end behavior is wrong again. So this is also not a polynomial. And then last but not least, this guy, right, as I trace the graph, notice how I have to keep lifting my pencil up to contend with what are eventually called vertical asymptotes. So this is not a polynomial. Alright, so these guys right away are ruled out in terms of not fitting polynomial behavior. They may be smooth and continuous, but their end behavior is not bounded. Their end behavior might be unbounded, but they're not, they're not smooth. Here, the end behavior is wrong, as well as the fact that there's breaks in the graph, so it's not continuous. So we have 4 of my graphs that are not polynomials, all right? And then it looks like what? 8 of them are. So we can now go answer some more questions. But what I'm going to do is do that in a new video, all right? So let's pause. We've answered A, right? We've determined which graph represents the polynomials. We'll do B and C next.